Hello everyone, hope you are doing good. Welcome back to my channel. Today we are at day 5 for the March daily lead code challenge, and as we are continuing, this again a question which is related to maths, and this is one of those questions where it's totally maths. Like, say, this kind of questions I've usually seen in Code Forces platform, but even in lead code there are some questions like this. So even like, see, first of all, we'll try to solve it using the programming approach. We'll try to without using much of maths, we'll try to solve this question. And in the second approach, we will solve using exactly maths. Okay, I will be showing you all the detailed calculation, like how this particular formula is coming, all that. With this solution, we will be able to beat 100% of the solutions. But if you are not aware of this, still using the normal programming approaches itself, you can get the solution. But yeah, this will be O of one solution. Okay, but the second one will be O of one solution. Okay, this will be over one basically. Okay, that's why it's very 100%. So I will show you both the solutions. Before that, let us quickly go into the question. It's 2579. Count total number of colored cells. So basically, if you see the input, you are just given a value n. Okay, the n will tell you that this many number of minutes are there in this game. Okay, so what will happen is, in the first minute you will be given a single square like this. Okay, that is single colored tile. Okay, now after every other minute, okay, in the first minute you are given a single colored tile. In the second minute onwards, and so on, from every minute after the first minute, what will happen is every adjacent cell of the current colored cells, please understand this very cleanly. For the colored cells that we have currently, for that we'll go to all the adjacent cells, and then we'll start coloring them. Okay, so if you see in the n equal to 1, we have only single tile. But in n equal to 2, all the four adjacent cells, okay, because this is a square, so it will have four corners, four adjacent, four, I will say, like, sides. Okay, so all the four sides are connected to other tiles. So all the four adjacent tiles in n equal to 2 will now get colored. Okay, so the idea here is that every minute, all the adjacent tiles that we have for our colored structure, okay, all the uncolored adjacent tiles that we have for our colored structure will get colored. Okay, so see, in n equal to 1, we have a single square. For n equal to 2, for the single square, there are four adjacent cells, so all the four now got colored. Okay, similarly for n equal to 3, if you see, all the adjacent cells for the current structure will get colored now. Okay, as simple as that. So remember, if it is already colored, we will not do it anything. But if it is not colored, then we will make it colored. Okay, as we go from one minute to another. Okay, so this is how it will be done. And yeah, this is for n equal to 3. So let us quickly try to understand what is happening. So we will see, at n equal to 1, the answer is 1. Okay, that is, this is like a base condition. Okay, this, we don't need a logic for this, because this is a starting condition, so we will not look for a logic in this. Okay, so we'll start looking for a logic from n equal to 2 onwards. So for n equal to 2, let us see what is happening. The answer is going to be, in this case, 1 plus 4. Okay, so if you see, 1 is there already, and we got 4 new ones. Okay, why this 4 came? Because every, see, the n equal to 1 itself is a square, right? Square will have 4 adjacent sides. That's why all the values, all the tiles which are adjacent to that particular cell on those sides will now get colored. So that is the reason why this 4 is coming, right? Now for n equal to 3, if you see what is happening, so just try to count what are the new cells that came. It will look like this. Okay, it will be 1 plus 4 plus 8. That is, from n equal to 2 to n equal to 3, the difference that is coming is this 8. Okay, a new 8 is getting added. Similarly for n equal to 4, if you see, this 12 will get added to the previous answer. Similarly for n equal to 5, if you see, the 16 will get added to the previous answer. Okay, so this is how it is coming. You can go through it, maybe pause the video, go through it, and then we'll try to see how we are getting a logic here. Okay, so see, like, instead of looking in this like this, what we'll do is, we'll try to correlate every answer with the previous answer. Okay, in this case, you see, we are talking about answer for 2. We are getting answer of 1 plus 4. Okay, see, this is the answer of 1. Okay, in that we are adding 4, so it can be written as answer of 1 plus 4. Okay, similarly for n equal to 3, it can be written as answer of 2 plus 8. Okay, because this is the answer of 2. Okay, this is the answer of 2 basically. In the same can be written, and we are adding 8 to that. Okay, so it's the answer of 2 plus 8. Similarly for n equal to 4, if you see, this is the answer, right? So this can be written as answer of 3 plus 12. Okay, similarly for n equal to 5, this is the answer, right? This can be written as answer of 4 plus 16. Okay, this is the answer of 4. We are just capturing this here, and instead of writing this separately, we are writing just the answer of 4, and then we are adding 16 to it. Okay, yep. So basically, this is the logic that we're getting. Answer of I is equal to answer of I minus 1 plus 4 into I minus 1. Okay, so see, because this is n equal to 5, and we are having a 4 here. Okay, just see the logic. See, here it's n equal to 4, and we are having a 3 here. Okay, similarly, that's why I'm writing for an answer of I, we're writing I minus 1 here, and this I minus 1 is getting multiplied with 4. Okay, and the other previous answer. So like this we'll starting, but yeah, remember, this formula will be applicable for I greater than 1. Okay, this will not be applicable for I equal to 1, because we are having a minus 1, so this will not be applicable. Always for I equal to 1, we'll be having a distinct answer. So see, this is how I'm starting. I'm keeping answer is equal to 1, and then I'm starting from 2. Okay, I'm starting from 2, I'm going till n. Okay, from 2 till n it will go. Okay, as simple as that. That's why I'm writing n plus 1 here, because I want the loop to go from 2 till n. Okay, what I'm doing, same thing. Answer is equal to the previous answer plus 4 into I minus 1. Okay, the I will be coming from this. I is a variable which will be changing in every iteration, and we're just doing answer is equal to the previous answer plus 4 into I minus 1. Okay, like this the answer will keep updating, and for every iteration we'll use the previous iteration's answer, and then we'll calculate the new answer, and this new answer will be becoming the old answer for the next iteration onwards. Okay, and so on. And the last iteration, the value that we are getting, that will be written as the final answer. Okay, if I can run this and show it to you, as you can see, this is playing all the test cases, and yeah, this is the logic for this. Okay, this is the final logic for this. So you can segment this will also work. But yeah, like if you see the time complexity, it is going to O of n. We are not using any space because we are using just a single variable, so it is a constant space complexity and O of n time complexity. Okay, this was one idea. Now the same thing, whatever I'm showing you now, the same thing we will try to try to find a pattern here further. Okay, see, in this pattern what we found is we are trying to relate it to the previous answer. Okay, but we will try to even avoid that. So let us see the next case. So this was the solution one that I've shown you currently. Now we are going to solution number two. Okay, so see, the solution number two will beat 100% of test cases. Now please pay attention here in understanding what is happening. See, till this part we have seen. Okay, till this part we have seen. Now please pay attention, because here the math is starting. You just need a few logic and see, you just need a few observations and obviously slight logic building, and then you are finally done. Okay, now see, what I'm doing is I am taking this 4 common. Okay, so for n equal 5, this is the answer, right? What I'm doing is, for these 4 values I am taking 4 as a common. So if I take 4 as common, what will happen? It will be written like this. Okay, something like this. It will be 1 plus 2 plus 3 plus 4. Okay, something like that. So see here, when we are at n equal to 5, this is coming till 4. Okay, till 4 it is coming. When we are at n equal to 5, it is coming till 4, right? Now when we are at n equal to n, what will come? It will come like this. Okay, 1 plus 4 into 1 plus 2 plus 3 plus, like that, till n minus 1. Okay, so whatever is the n value, 1 less than that, we will go till then. Okay, 1 plus 2 plus 3, like that, till n minus 1 value. So if you see, for n equal to n, what we are getting, 1 plus 4 into 1 plus 2 plus 3, like that, till n minus 1. Okay, now please stop here. Now see, we will try to find a formula for this. How to find? See, we know this, that, see, let me remove this part because this we used in the last solution. Yep, if you see, this is a common formula which we all have learned in our maths in some lower class. I don't remember the exact class, but in some lower class we would have learned this pattern. Okay, what is this? See, 1 plus 2 plus 3 till n. Okay, if you do 1 plus 2 plus 3 plus something like plus like that till n, if you do, the final answer that you're going to get is equal to n into n plus 1 by 2. Okay, you can google this out. You can even verify this in your maybe some previous textbooks, but this is what it is, right? So I am sure that you will be knowing this, because if you're preparing for interviews, like for some small companies, especially for those mass hiring companies, they will ask maths question. Okay, so maybe like this kind of things you might have learned to crack the aptitude round for those kind of companies. Okay, so this will be really useful for that. Okay, now if you see, the sum of all these numbers till n is from 1 till n is going to be n into n plus 1 by 2. So same formula now we are going to use. So see here, if it is n, okay, if the last value is n, you have to write n into n plus 1 by 2. Okay, in this case the last value is going to be n minus 1. So what you have to do, wherever n is present, okay, wherever n is present in this, just replace it with n minus 1. Okay, so what you are going to get, you are going to get like this. Okay, 4 into n minus 1 into n by 2. Okay, so wherever n is there, you have to replace n minus 1. So this will become n minus 1, this will become n and divided by 2. So this is what you are going to get, 4 into n minus 1 into n divided by 2, and finally we are adding 1 to it. Okay, now if you see here, 4 is there and here 2 is there, so we'll try to obviously reduce them. So this is what we are going to get, 1 plus 2 into n minus 1 into n. Okay, so this is going to be the value for n equal to n. Okay, so this is going to be the answer. So now see, previously what we did, we tried to get the answer using the previous answer. Because of this reason, we had to we had a complexity O of n. But now, since see, we don't need any previous answer now. If you see this term, it only depends on n. Okay, and we are already getting n. Okay, so we don't need to find any previous answer. We can directly calculate this value, and this will be the answer. Okay, so we don't need to go for a for loop or all those things. Okay, if you see, directly we return this answer for the given input n, the answer is going to be 1 plus 2 into n minus 1 into n. Okay, this is going to the final answer. If you segment this, your solution will obviously be 100%, because it is see, O of 1 space and O of 1 time. Okay, it is not taking any space and any time, because we are not using any for loops or any variables for that reason. Okay, it's a total constant. Okay, everything is constant here. Okay, for whatever value of n, this will be always constant. Okay, so yep, this was the solution. See, I felt that, see, for it is 10 power 5, right? The complexity is still 10 power 5. Okay, so for 10 power 5, running a for loop for 10 power 5 iterations is too much according to me. This solution, if it is possible, obviously we should go for this. Okay, this was an easy math question. If you just find the pattern, obviously you should know these things. You should have at least exposure to this part. That, see, I will tell you this very frankly. If you are in an interview and if you are able to find till this point, see, it's not, there's no harm that let us say you don't remember this formula, okay, but you have found till this point, okay, maybe you can ask the interviewer's permission and then just go on Google and get this formula, okay. You know that, yeah, there is a formula for 1 plus 2 plus 3 like that till n, there is a formula. Just go and Google that formula out and then use it here to get your answer, okay. You can do that. Remember, it's not a harm, okay, it's not a crime like that. You are able to find till this point, but you don't remember the formula for 1 plus 2 plus 3 like that till n, okay. You just don't remember the formula. You can definitely, in the interview also, you can ask for the interviewer's permission and then go and Google out and get this formula. Maybe the interviewer will give you this directly. Like, if you say that, okay, I've come till this point, I know there is a formula to reduce it further, but I don't remember it correctly. Maybe he will help you out with the formula. Otherwise, he will ask you to, go do a Google search, okay. That is how it should be. And yeah, see, always remember, in a programming interview, only your programming knowledge needs to be tested. But yeah, sometimes even with programming, some math knowledge will also get tested. It's no harm to accept that, yeah, I know there is a formula, but obviously I don't remember it by heart. So let me, like, can you give me a hint, or can I just Google search? You can ask them. If possible, if you know some hints, maybe you can devise it by yourself, okay. For example, see, you can take maybe like 1 plus 2 plus 3 like that. You can take small numbers, substitute and with that value and try to get it, okay. So see, like initially I thought it will be n into n minus 1 by 2, okay. Then I checked it for n equal to 3, okay. I did the sum and checked whether it's coming correct or not, and then I realized it will be n into n plus 1 by 2, okay. So like that you can do and get the formula, okay. So that is my hint. See, that is all I can tell you for this question. If this question comes, what all you have to do, see, first of all, try with the programming approach with the previous value. See, this is kind of a this idea you can get from a prefix, some kind of thing, okay. What we are doing is we are taking the previous value and then we are getting the current value, okay. So this is the same kind of approach that we use for a prefix sum, okay. But yep, that is different, this is different, I agree, but the ideas are same. And then if you know the maths, you can get to this kind of solution, which will beat 100% of other solutions. So yeah, friend, that was all for this particular video. This question was slightly on the easier side if you recognize the pattern, okay. If you are not recognizing the pattern, it will be difficult for you. So yep, that is all I can say. Yeah, friends, see you tomorrow. If you like my efforts, if you like the quality of this content, please do subscribe to the channel. This will help us create further videos. This will give us a reason to create further videos so that it helps many people. This was our 134th video. So, and let's see how many more days we can continue. See you tomorrow. Thanks a lot.